Good morning, I am Dr. CHS Fanikumar. Today's topic is size separation. So, these are the contents to be learned out of this topic. Size separation, objectives of size separation, official standards of powders, sieve, mechanism of size separation, sieve shaker machine, cyclone separator, air separator, illustration tank, bag filters. About all these contents we are going to discuss under this topic. So first let us learn what is a size separation. See, generally size separation is the process, the mixture of particles which are having different particle size are separated into the individual particles by means of a filtering medium. See, this is called as size separation. So in this the individual size of the particles are separated from the group of particles having different size. Such a unit operation is called as size separation. Coming to the various objectives or applications of the size separation process. See, first one is generally this is used to determine the particle size in production of tablets as well as capsules. See, in production of tablets or capsules, first we are going to use the powder to fill into the capsule. The powder consists of various sizes of the particles, as well as tablets. The powder is compacted into a tablet. So by means of compression of powder, you are going to prepare it as a tablet. See, in both the processes, flowing of the powder from the hopper plays very important role. The flow properties are depending upon particle size as well as particle size distribution of the powders which are present in a powder mix. In such a way, this size separation is going to useful in production of tablets as well as capsules, as well as determination of the individual particle size which are present in the tablet mix as well as capsules. Coming to the next one, to improve the mixing of powders. As I told previously that particle size distribution. Particle size distribution is very important one. That means there should be a required ratio of core sized particles to the fine sized particles. So if that ratio is not good, then what happens? Usually that leads to the improper mixing. So to get the good mix, definitely what we have to do, first initially you have to separate the different sizes of the particles, as well as we are going to determine the ratio between coarse particles to the fine particles. In such a way you are providing an efficient mixing by means of the size separation. Coming to the next one, to improve the solubility and stability of particles during production. Yes, ultimately solubility is depending upon particle size. So lesser the particle size, greater the surface area. Greater the surface area, greater the solubility. By that bioavailability of the drug is more. Okay, for which purpose initially as a tool we are going to determine the solubility with the help of the same. So particle size should be having a critical size, okay, at which they are having great solubility. In such a way we are going to study about their. Coming to the stability, in preparation of suspensions, these particle size plays very important role. Why? Because suspension means a dispersion of insoluble particles in a given solvent system with the help of suspending agent. So if a particle size is more, the density of particle is going to increase, that leads to sediment within the given solvent system. So that leads to the what is that descending of the particles, leads to the cause the instability of the dispersion. Okay, in such a way, what we can do, we can determine the stability also. If particle size is directly proportional to the density of a particle, more the density, more the sedimentation. In suspensions, sedimentation is the major defect of the suspension. You should avoid by maintaining the optimum size of the particles. In such a way, we are going to use this one. Coming to the next one, to optimize the feed rate, agitation, screening during production. Ultimately, based upon the particle size only, we can provide all these parameters to get the good production of a product. Coming to the next one, for the quality control of raw material. Yes, ultimately, as we discussed, so many parameters in which particle size plays very important role. With the help of size separation process, we are going to do the quality control for the raw materials in such a way. Coming to the next one, useful in the production of tablets. As we discussed earlier, for production of tablets, initially flow of powder from the hopper is very important parameter, as I said previously. Okay, as well as solubility of the product. That means tablet, drug present in the tablet, as well as its stability, all those are depending upon the particle size. So, in this, all those aspects, we are going to evaluate the size of the particle. So, in such a way, the size separation process is going to be useful useful in the production of the tablets in such a way. Coming to the last one, preparation of ointments, creams and some other dispersions. Okay, we are going to evaluate the size of the particles by which you are going to maintain the good dispersions. Okay, usually these ointments, creams, all these are the dispersions, semi-solid dispersions these are. So, in all these we are going to use this size separation effectively. Coming to the official standards of powders, usually Indian Pharmacopoeia prescribes the standards for the powders. That means based upon their size, they are classified into the different types, as well as let us see their definitions also. Coming to the first one, coarse powder. See, coarse powder means what? Whenever any size of the particles which can pass through the sieve number 10, that means that is having aperture size of 1.7 mm and 40% of particles can pass through the sieve number 44. That means all the particles can pass through the sieve number 10, but 40% of particles can pass through the sieve number 44. Such a size of particles are called as coarse powders. Coming to the moderately coarse powders. Okay, the powders which can pass through the sieve number 22 and 40% of the particles can pass through the sieve number 60. Such a size range of particles are called as moderately coarse powders. Coming to the next one, moderately fine powders. Okay, generally these moderately fine powders will passes through the sieve number 44. 40% of particles can pass through the sieve number 85. Okay, as well as fine powders. Okay, generally the particles which can pass through the sieve number 85, those are called as fine powders. Okay, coming to the next one, very fine powders. The powders which can pass through the sieve number 120, they are called as very fine powders. In such a way, based upon their particle size, we are going to discuss about the Indian Pharmacopoeia differentiates the various sizes of the particles. Coming to the next one, generally for the size separation process, we are going to use one medium. Okay, so the medium which is used for separation of particles is called as a sieve. It is called as a sieve. Generally, what is a sieve? Sieve means, okay, it consists of the aperture openings, okay, which are formed by means of weaving of the wires of a different material. So let us discuss what are those materials. Usually with the help of cloth we can frame the sieves, okay, as well as from the wires which are from the brass we can woven them. okay, as well as bronze, stainless steel, or any other suitable material, by using which what we are going to do, we are going to produce the wires, okay, and these are getting woven by means of the same. So in such a way they are going to form the sieves, okay. By using these sieves we are going to separate the different kind of particles. And coming to the consideration about the sieves, okay, generally these sieves is prepared by means of a material of construction. The material of construction should not be incompatible with the material which one we are going to passing through it. In such a way we are going to select the material of construction. That's why cloth, as well as brass, as well as bronze, as well as stainless steel, such a kind of less reactive materials we are going to choose to prepare the sieves. Okay, coming to the different specifications about the sieves. Okay, see, coming to the first one, number of sieve. Okay, what do you mean by number of sieve? If you consider a length of 2.54 centimeter on a sieve, for a length, okay, how many number of openings are there? That is called as a sieve number. Already we have discussed in the definition of various sizes of the particles. So sieve number 10 we have discussed, where sieve number 10 means in the length of any length of 2.54 centimeters on a sieve, how many number of openings are there? Sieve number 10 means it is having number of openings are 10. If it is 60 number of openings are there. If it is sieve number 80, it is having 80 number of openings on that. Coming to the next one, nominal size of the aperture. Nominal size of the aperture means what is the distance between two wires. What is the distance between two wires? That distance is called as nominal size of aperture. Nominal size of aperture. These are the different kind of sieves which one we are going to use for what? Size separation of various kinds of particles. Coming to the next one, nominal diameter of the wire. Already we have discussed, by means of wires only what we are going to do, we are going to prepare the sieves. Okay, so that wire, how much diameter it is having is known as a nominal diameter of the wire. Okay, coming to the next one, approximate percentage sieving area. If you consider a total surface area of the sieve, total surface area is not used for sieving purpose. Okay, under which only some permitted area or only some area is utilized for the sieving. So the area which is utilized for, which is useful for the sieving process, divided by total area into 100 gives you what? It gives you approximate percentage sieving area. So in such a way we can discuss about the specifications of sieve. And coming to the last one, tolerance average aperture size. See, usually if you consider the aperture size, okay, sometimes it is unavoidable. It is unavoidable. So that means it is having some variation. So that variation as a percentage which is called as a tolerance average aperture size. Okay, in such a way we can discuss about the specifications of sieves. Coming to the mechanisms of size separation, that means how we are going to separate the particles by means of sieving method. Okay, so first we have discussed about the definition as well as whatever the device used for separation we have discussed. Okay, now we are going to discuss about by which mechanism, by which principle we can separate the particles. We are going to discuss now. Coming to the mechanisms of separation, there are three methods. First one is agitation, and second one is brushing, and third one is centrifugation. Okay, see, agitation, generally if you shake the sieve by mechanically or by means of any means, if you shake it, okay, then what happens? Particles will pass through the sieve forcibly and they are going to pass through their openings. Okay, that means the size separation is going to happen. Coming to the brushing, in brushing what we are going to do, by means of a brush forcefully we are going to pass the material through the sieve. Coming to the centrifugation. In centrifugation, what we are going to do? We are going to use a centrifuge in which we are going to place a sieve near to the walls of the centrifuge, and you are going to place the material which is to be separated, and you are allowing it for the centrifugation. So, what is the principle of centrifugation? Separation of the particles takes place by means of their density. Okay, so because of their density, what happening there? They are going to thrown onto the surface of the wall. When they are thrown on to the surface of the wall, they passes through the sieves and they are getting separated. So let us see. First one is agitation method. In this agitation method, again we are going to use three kinds of techniques. What are those? Oscillation, vibration, as well as gyration. Oscillation means what? It consists of a wheel on which we are going to place a sieve, and we are going to allow it to move through and through. We are going to allow it to move. Okay, so we are going to place the sieve on a slant position, and we are going to allow it to move on that wheel. So it moves through and through. So once it is moving through and through very speedily, then what happens? Passage of the movement of the particles on that sieve is going to happen. This force is going to force the particles to pass through the sieve. In such a way, in oscillation, we are going to separate the particles by means of oscillation movement. Okay, by means of agitation. Coming to the next one, vibration. By means of electric mean, what we are going to do? We are going to apply the vibration onto the sieve. So when the vibrational frequencies are more, then what happens? Whatever the particles can pass through the sieve can be separated from the powder mix. So in such a way we are going to separate the particles. Coming to the gyration. Gyration means what? Usually spinning of a sieve by means of an eccentric wheel. Spinning of the sieve by means of an eccentric wheel is called as gyration. So in this gyration, what happens? Agitation is going to occur. That agitation leads to pass the material which can be passed through the apertures. In such a way, by these principles, the size separation is going to be happen.